Welcome everyone to Corporate Review. I'm your host, Ara Tapuzzi, and I'm the City of Novi's Economic Development Director. And each episode we travel around the city and check out the businesses that you may not be aware of, one of which is here right on Cabot Drive, Ellison Technologies. I'm here with Russ Atkinson. Russ,
Eric,
thanks for having us come in.
Thanks for coming, Eric.
Driven by this building a lot of times. Matter of fact, when I tell people I'm going to go see Ellison Technologies, they kind of look at me funny like, who's that? And then I have to tell them Mori Seiki, and they go, oh, okay, because they've seen the sign. Give us a little bit of a background on Ellison Technologies and who you folks are and what you do.
Sure. In our simplest form, we're a machine tool distributor.
Okay.
We sell machinery. We don't build them. We represent DMG, Mori Seiki, and a couple other brands. Think a car dealer, if you will, that a Ford dealer might have somebody else's name on the door, but he sells the Ford product. We're like that.
Okay.
And again, in our simplest form, we sell the machines. But it would be an injustice to our company to leave it there. We sell the ability to make the parts. We work with our customers to help them compete, to make those parts and be able to compete both globally and locally and to win. And to do that, we take those machines and we apply peripheral products, tooling, computer programming, automation, et cetera, to help make that part less expensively in a more cost-effective way.
Okay, so in essence, Ellison Technologies represents these two brands. Go back a little bit because, you know, as I sort of joked, no one had heard of Ellison Technologies. It was always Mori Seiki. So you folks haven't always been here.
That's correct. Right. Mori Seiki moved into this building in 2005 as a direct seller of their own products. Okay. In 2006, they realized that maybe there was a better way to get their product to the market. While they're an excellent builder, Ellison has expertise in interfacing with customers, et cetera, and they felt we could be a better representative to the customers. So in 2006, we became the representatives and we took over this facility that Mori Seiki had spec'd out.
Okay, so tell us a little bit about Mori Seiki, Japanese company, and then also this newer brand, this DMG.
Mori Seiki is a company that came out of the ashes of World War II, formed in 1948 to build textile machinery. Okay. And from that, they expanded into building the machines that make the textile machines, et cetera, and began by making manual, hand-operated machinery, lathes, and then expanded. Today, they're one of the world's largest builders of machine tools, probably fifth or sixth largest company in the world that builds machine tools. DMG, which is Deckel, Maho, Gildemeister, is a combination of three companies in Europe that back in the 70s formed a joint venture to represent their product, to build their products and represent their products. They are European, and they are probably second largest machine tool builder in the world, and have approximately 40% market share in Europe. But they're not known as well as
Mori Seiki.
Mori Seiki in Japan, and in different parts of the world, different products are better known. These two companies merged about 2 years ago in a marketing joint venture. They're gradually putting their financials together, and each now owns a portion of the other.
So they both complement each other.
Correct.
You know, as far as
where one is strong in a particular type of machine, the other has a complement machine in a different area. When they first merged together, their products did overlap, and about 25% of the machines that DMG built, Mori had a similar product. Over the course of the last couple of years, that product similarity issue is being sorted out. So the two companies in their collaboration are working to have an advantage in manufacturing. DMG manufactures in Europe. Mori manufactures primarily in Japan, although they're now building a factory in the United States as well. So think globally, think in terms of the economic situations in the different parts of the world, and think in terms of the financial issues with the dollar to yen, euro to yen, et cetera. Mori and DMG can now move their manufacturing around, and
it's a good alliance.
And it's an excellent alliance.
So we've been up here a lot. We're looking at these signs, and people are going to say, when are they going to move around and start looking at stuff? The whole show is not the signage here. Yeah. But we're going to go in the back, and you're going to show me really the guts of this operation.
Absolutely.
All right, let's go.
Okay.
The Novi Business Assistance Team is a free resource designed to assist small and medium-sized businesses. The goal is to provide knowledge, guidance, and useful tools that business owners can utilize to help their businesses grow in an effective and efficient way.
The Novi Business Assistance Team includes representatives from the City of Novi, the Novi Chamber, Oakland County, and the SBTDC. The best part of a BAT visit? No cost. If you are a business based in the City of Novi and you've been in business for a minimum of 2 years, you qualify for a BAT visit.
For more information on the Novi Business Assistance Team and economic development, visit investnovi.org.
All right, so Russ, what's all this ancient stuff?
Exactly.
Everyone's going to think, hey, what are we watching this show for? But you did this for a reason, so let's talk about this.
I did. A couple of things. I said earlier, when we say machine tools, a lot of people think hammers, screwdrivers, wrenches, etc. And that's not what a machine tool is. This is a fundamental machine. And I like to start here if people aren't familiar with our industry, because it illustrates where we came from, and then we can later go and show you what we do today. Yeah. But this is a fundamental milling machine. It makes prismatic parts, and this is a fundamental lathe that makes round parts. And this is the foundation for the types of machines that we sell. Lathes for round parts, again, mills for prismatic parts. I left this machine dirty for a reason, because if we were to talk to mom and dad and say, as a kid, I'm going into manufacturing, I'm going to go to a place that makes a machine shop. Mom and dad typically think of this. Chips on the floor, dirt, oil to cool the chips. That goes all over the place, and you can see the floor hasn't been cleaned. We swept it up a bit. But at the end of a manufacturing day, 20 years ago, this is what the factory looked like. And the operator took 15 to 20 minutes just to clean up, and that was lost production. The other thing that you notice on the machines is that the operator, to make this work, is turning handles. So it's a
very manual.
A lot of manual input and a lot of skill that was required.
And how far does this technology, for lack of a better term, go back?
That machine was probably designed in 1920, and you can still buy it today in 2012. We have them here. We actually use them to make brackets and small components in the process of putting a turnkey together. And sometimes it's a lot easier to just walk over in your home. You could have a drill press in your basement for drilling holes.
Of course.
You could have
doesn't everyone?
A hand drill. Everybody uses a hand drill. If we're making parts in a manufacturing environment, we're not doing it like this anymore. It went from this, well, we used to say sharp stick and a rock, to drill, to this machine, to the technology we have in the other room.
Offline, you were talking about what I thought was very interesting, the workforce behind the manufacturing industry. And before we go to the other side of the warehouse here to show where this has changed, talk a little bit about that. That's the workforce environment for manufacturing, not only in Michigan, but in the States, change. How have you seen it change?
One of the biggest issues that we face in our industry is that in the next 10 years, half the workforce will retire. And America is not replacing the workforce. So we're critically, we're concerned about what's going to happen to manufacturing. It's not all right to let manufacturing go away from the United States. So part of our job, helping our customers compete both locally and globally, is to help them with training, to help them develop the skills. Okay. And in some cases, if the skills of the operator are going away, we've got to put those skills into the machine.
Right.
That technology transfers from the man to the machine.
So the newer workforce, which is a small number, they even know how to operate any of this older machinery?
There's a good chance they don't.
Yeah.
And sometimes we have to teach the fundamental skills on how to machine as a foundation. But what's interesting, we'll bring kids into an open house. Yeah. They've never been around a machine. And the first thing they do is walk up to the computer and start playing with it.
Of course.
Guys like you and me are going, you know, I can do this, but I don't know about that computer.
Right.
Kids are not afraid of computers, and we're attracting the young because of the computer technology that's in the machines today.
Okay. Let's go take a look at that technology.
Very good.
Okay, so we went from old to new.
We have.
We've jumped a few decades. So talk about this machine. How does this relate to the drill and the lathe that we just saw?
Well, the machine, the chips on the floor, the fundamental machine is right here. Okay. And although you can't see this is what is on the factory floor today. Okay. It's a clean environment. I've got a computer. The technology that people are familiar with, the kids are familiar with today, is what's actually running this machine. Okay. But the fundamental machine is still the same. Okay. Here's the spindle that holds the tool. That's what's inside this box. Right. I've got a table that moves left and right and in and out, exactly like that machine that we saw in the other room. Okay. The difference is there's no hand wheel. Sure. It's all servo motors, electric motors that are driving the machine, and we tell the machine where to go with this computer. Now what's running through here is the program that's actually telling the machine where to go, how fast the spindle should spin, and how fast the axis should travel.
Looks like a doomsday device, really.
I hope not.
I'm going to take your word for it, but how quick? I mean, obviously, the difference in speed alone has got to be remarkable. How fast can this machine cut a tool?
It's a real difficult question to answer because it all depends on the part itself. Right. The axes move at 1,500 inches a minute. There's no way you can spin a part that fast by turning it by hand. Although we can engage some power devices on that machine, we're looking at 3 or 4 times as fast to make a part versus the old manual way to make it.
Okay. So now you've said throughout offline and online, no machine works alone.
Correct.
It's very much of a teamwork. So you've got another component that that I'm very interested in. You're calling it the chip blaster. Can we let's talk about that a little bit? Okay. Because I found that to be pretty interesting. What does this do? This doesn't make ice cubes, apparently.
It absolutely does not. But we go back to the technology in the other room. Yeah. I picked up a can of oil. Right. And that can of oil is used to lubricate the tool and to actually cool the cutting process. Right. And in old days, a guy dripped oil onto the part. Sure. That oil went all over the floor. We made smoke, etc. Right. Today, very seldom do we use oil.
This replaces the oil can.
This replaces the oil can. And you think, well, what a big deal. Yeah. But the technology of cooling the chip is as important as making the chip in many ways. And this probably is a good place to use this picture. Yeah. When you're drilling a hole, right, we can just push the drill down. And I don't know, when you drill wood, sometimes you get the smoke and the drill gets all gummed up with wood chips. And you ruin the bit. You ruin the bit, or it's real hard to push the drill. One of the important things about drilling a hole is getting the chips out of the hole. Or we continue to recut them, the chips, and it causes wear on the drill and slows the process down. We can drip oil down in there to help lubricate the drill and help the chips evacuate. Today, that device will push the coolant down the center of the drill, and you can see it coming out of the tip. That's coming out at 1,000 psi pressure. That forces the chips to come back up the flutes. We're pushing the chips out of the way so they're not recutting. The other thing that the high pressure coolant does, it actually penetrates a barrier, a heat barrier that develops between the cutting tool and the work itself. And when we can penetrate that heat barrier, we can increase the cutting speeds of the whole process.
So does something like this go with pretty much every machine? I mean, it doesn't.
We select, there's a place where this has an improvement, and there's a place where it doesn't. All of these machines, we have a coolant in the machine that comes standard with it, but the pressure is about 65 pounds per square inch, and it doesn't go down through the center of the tool typically. So when the right application comes along, and this is part of what we do, is help the customers choose the peripheral products that help to make the machine more productive. We'll select something like a chip blaster.
Now, Russ, when we were walking around earlier, you had a machine like that in the back, kind of all wrapped up in a crate and ready.
I have one exactly like that in a box, ready to go.
Are you shipping globally, just within the United States? I know you're getting product from overseas.
From overseas. Our primary focus at Ellison, Michigan, is to help customers in the state of Michigan. But if they have a plant in Poland, if they have a plant in Mexico, China, etc., we'll ship. We didn't look at it, but there's a machine out back that is being crated up and will go to a customer's plant in Mexico. I have support in Mexico, so when that arrives there, we'll install the machine, we'll work with the customer there to help that machine get up and running.
All right. We got one more fancy machine. We always save the most
the best for the last.
The best for last.
Right.
So why don't you show me where that machine is?
Right over here.
All right, so this is the fun machine, right?
This probably demonstrates best what we do. Because all the pieces
this is
get
the
put together.
NV5000.
It's actually Maury's flagship. We have that machine and this machine basically do the same thing. This is just, well, a little higher grade of technology in the machine, but fundamentally does the same thing. Same controller, same three-axis of motion. But inside the machine, there's actually, that one has this similar to the little old hand wheel-driven machine, three-axis of motion. This one has a fourth axis of motion. On the table, we have a rotary device that actually rotates the part. But if we step back from the machine for a moment and realize by itself the machine doesn't do anything. Remember the little manual machine with the chips all over the floor? Now I've got chip management. Okay, so we're getting the chips out of the machine, and if this thing were actually in a production environment,
this would spill out to something else.
Into a barrel or into a conveyor.
And I noticed you've got another one of those.
High pressure coolant unit married to the machine. That added improvement to the cutting process for this application. Over here, we've actually added automation.
Will this turn my television on too, or
no?
no?
Probably. This is actually the controller for the robot to program the robot. So now we had a customer that said, I need to make parts and I need to make them in a production environment, and loading, unloading slows the thing down. I got to have an operator tied to this machine where now I can have that operator being much more productive if he's not just loading parts. So basically the parts get loaded into trays here. The robot then pulls the trays out as the parts are needed, picks the part out of the tray, inserts it into the machine. The machine
does its work.
The robot then takes the part back out and puts it back into a finished tray.
Is this where the technology has ultimately just gone to? I mean, you've only got one of these robotics here, but I think more for demonstrating for us today. But all these machines, I mean, is that component very much important to it? Or I know that people are, some say the robot is replacing the skilled worker, and I mean, how does that fit into the entire model?
Back to what our goal is. Our mission is to help our customers to compete and win, both globally and locally. In some cases, a robot is going to replace man. Back to the other problem we're faced with is that our workforce is retiring
Right.
and not being replenished.
And if you're going to stay competitive,
You have to stay competitive. In some cases, automation is a way to not replace the man, but to make the man more productive.
Right.
And allow the
Makes sense.
factory personnel to do other things besides just stand here loading and unloading parts. Now, take another step back, I still have to have somebody program this.
Sure.
So I don't necessarily replace.
It's not right. Okay. Very
Replace
good.
labor. We may have transferred the skills to another area.
Okay.
Today, people are much more familiar with computers and would rather stand in front of a computer to figure out how to make that part than to stand in front of a machine and turn a handle.
Less laundry they need to do when they go home at
Yeah,
night.
we don't have chips
I mean, it's
on the
perfectly
floor.
clean in here, and that's also how manufacturing has really become to be very clean. The old days of heavy industrial, loud stamping noise. I mean, it's a little noisy in here, but comparatively to what it once was, it's a big difference.
You're absolutely right.
So now we've seen all these machines, but we got to actually see what they've done because we can't see anything in here. So we're going to take a look. You've got a showcase full of different tools.
Showcase, and I've got some parts laid out that we can take a look at.
Well, let's go over there and ramp the show up.
Sounds great.
ノバイはミシガン州南部で最大のアジア人口を誇り、市内には50以上の日系企業があります。詳しくは市のホームページをご覧ください。
All right, so these are real products.
These are
correct?
real parts that have been made on machines that we have sold to customers.
And so this was originally,
This started looking like this. So it came to us as it looks like a forging in this particular case.
Okay.
And we machined this to make that. So think about the operation that we had to do. We had to turn it
right.
on a machine that made round parts. Somehow we had to put those holes in it, and somehow we had to cut those slots.
Amazing.
And then this will go into probably a transmission or some type of a powertrain.
You've shown me this one before.
Yes.
And so again, this one would have just been what
That
more of
started from a solid piece of metal. And the interesting thing about this is in days of old, I would have probably had to hold the part like this, turn this part of it, then hold the part like this, turn this part of it, then send this to another machine to machine this spline. This was done on a specialty machine.
The older machinery, could it have done? I mean, this is perfect. I mean, is that also changed over the years? That with more modern technology, this is just a more not just streamlined, but a more perfect looking end result. I mean,
the
manually,
machine,
could they do this?
yes, we could make that part in 1920.
Okay.
No problem.
Okay.
I'm sure parts were like, but the difference was that it probably took an operator, had hundreds of them, picked it up, put it in the lathe, made this end of it.
Right.
Took it out, set it back down.
Right.
Forklift came over, took it to another machine. Another operator picked it up, turned it around, machined this end, set it back down. Forklift took it to a third machine, and this spline had to be cut in.
Okay.
Today, we can pick it up with a robot.
Right. So much time is saved.
Right. And make it complete. Because now, instead of having one chuck at one end, and then I have to turn the part around, I can have a chuck over here and another chuck over here. And we also have the capability to machine that spline. In fact, we made this part complete for the customer in one handling.
Right.
So the advantage to the customer was he never had to put it down once he picked it up.
Right.
And it was made faster and less costly.
So I'm intrigued by this actual product.
I put that there.
You need to explain yourself.
I do. You can't walk in your house and go with an arm's reach and not touch something that was made on a machine tool.
Okay.
This is a calculator, very simple, but think iPad, think Android device, whomever. And a fountain pen, and a ballpoint pen. I'll come back to that in a second.
Okay.
But the mold that this case was made on was made on a machine like that one right over there.
Oh, all right.
So you might find thousands of machines in one factory just making the cases for Apple iPods or Android devices.
And this is what the consumer, the end consumer
doesn't
viewers
see that.
are watching.
He sees
this is what they can relate
to. It doesn't
to.
relate to machine tools.
Yeah.
But we look at this and say, how was it made?
Sure.
And what machines are required to produce that?
Okay.
In itself, nothing, but the molds that had to make the plastic,
put it all together,
et cetera, were made on our type of machine.
Talk about the pen.
Pen. From Bic to Mount Blanc, that chip is made on a machine that we sell.
Okay.
By the millions. But it again, everybody picks a pen up, everybody has one in their pocket or in their drawer or something.
Right.
It's made on a machine tool. The mold that made the plastic for this pen, these tips were machined. All those were made on high-speed production machines today.
Wow, amazing. So everyday products,
Everyday
everything
product.
we know, like you said, within arm's reach, you guys have really touched it at one point. Talk, this is
pretty fundamental.
very heavy too, but I mean, this is very heavy. But if the camera could kind of get in here, I mean, the detail, I mean, you can just see where it's just been coiled right through, and one of those machines we saw that was sort of drilling in each of these holes.
That started with a block looking like that.
Right.
And then we machined part of it so that it looked like that. But back to fundamental machines. Prismatic part. This is a prismatic part.
Okay.
Okay. 6 sides to it.
Sure.
Drill holes in it. Machine something out of it.
Right.
By contrast, here's a round part. It was made on a lathe.
Right.
Either a manual lathe or in our case a very sophisticated lathe today.
Okay.
Now here's one, a little bit heavy. This is part of a turbocharger component. Now when you look at it, it's got, and there'll be other machining that's done on it, but here's round machining and here's prismatic machining.
Okay.
This was actually completed in one operation on a machine that did both. So the technology today is to take that fundamental lathe and that fundamental mill and put them together and make very sophisticated parts in one operation.
And Russ, we touched on the educational component a little bit earlier, but obviously we're right here and we've got 2 demo units, and these look very similar to what we've seen on the machines. But talk about Mori Seiki University, or as you ripped off MSU, I'm sure. Green and white probably doesn't have a problem with that, but talk a little bit about that.
These 2 controllers and this kind of go together.
Okay.
This is exactly the same as the computer that's on that machine.
Right.
It's a simulator. So when by the machine, if the operators don't know how to program the machine, we're there to help them. We can train them. This is for a mill and that's for a lathe or vice versa.
Okay.
But we have a classroom. The operators can come in and we'll teach them how to program the machine. We'll teach them how to run the machine. But going even further, we said earlier that 50% of our workforce in the United States is going to retire. And there's not a whole lot being done to help replace that.
Right.
Mori Seiki stepped up. They actually have a university today, and there's a whole array of different classes that somebody can take to learn how to run a machine, learn the fundamentals of machining, learning how to program machining, learning about tool technology, learning about the fundamentals of all the manufacturing can be gleaned from Mori Seiki's university.
And how successful has this been? Is this fairly new?
The last few years, but it's taken off.
Sure.
I wish I could cite the number of courses that and the number of people who've been enrolled, but they have a full staff that runs that university at Mori Seiki in Chicago.
Well, that's excellent. And then you've got a bunch of showcases over there, and just tell us a little bit about, and those aren't real parts you said earlier?
These, you want to walk over?
Yeah, let's do that.
Okay. The purpose of these displays is not to show a part that we've made, but to show machine tool technology.
Yeah.
And again, we talked about the fundamentals of machining. That little brass part that's there
Right.
It doesn't look very big, but the sophistication that's required to make that part is quite a lot.
Right.
So back to, if we made that part in 1920, it probably took 6 or 7 operations to make that part. We make that part complete today in a machine that does both machining and turning. Same with the parts. All these display cases just show different technologies that our machines,
the capability of the
capabilities
machine.
of our machines, correct.
How is this industry changing, you know, let's say 5 years from now? What do you see? You've been doing this a long time. Where do you see this technology going from here?
The move will continue to make the machines more sophisticated and do more operations combined, as opposed to having one machine do one specific thing.
Excellent. Russ, thank you very much for
Eric,
showing us around Ellison
really appreciate it.
Maury Saki. Now those of you that have driven by Cabot Drive here between 12 and 13 Mile and see the sign, Ellison Technologies, DMG, and Maury Saki, they can know what it is. I'm Ara Tapuzian, again, the city's Economic Development Director. Thank you for watching. If you want some more information on economic development and more information on corporate review, we invite you to go to our website, investnovi.org. We're on Facebook at facebook.com/investnovi. We're on Twitter as well. You can easily find us. Until next time, take care.